Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics. Welcome to Speaking of Reliability. This is Fred Schenkelberg.
And this is Carl Carlson.
Hey, Carl. Hey, we got a question. Actually, it was in this morning's email. It makes my day when I get one of those. And
That's right.
I get all kinds of comments and questions and stuff on a regular basis. But this one was like, I'm glad we're recording today. This is a really good topic. So a person asked the question and saying, we're doing demonstration tests for our product. And we've had a handful of failures. And is it okay that we don't count in the results tabulation and reporting of the demonstration test if they're maintenance-induced failures, supply chain quality issues, or manufacturing induced failures? Is basically was, do we only count the design errors? And I don't know that we're going to agree on this one.
Let's hope not. I mean, it's more fun when we don't agree.
Yeah, so. but anyway, he was looking for a quick answer, and I'll send him a quick answer, which you probably didn't like, which was, yes, you count those things. I mean, if you're demonstrating to if it goes back to what's the definition of a demonstration test, right? For me, it's the customer wants you to prove that your product works in use conditions or something close to use conditions. And they can point at it going, yeah, it'll meet our requirements. And so if you take a handful of products and you run them through some paces and it doesn't work for, in my opinion, any reason, well, your system's not there yet. Your process of design, manufacturing, supply chain, because the customer doesn't care that it failed because a supplier missed the target on one of the products, because that will happen again, right? Because your system is not in place to actually make sure you get good parts. If your maintenance practices and techniques induce a failure, you're not done with the design yet.
Yeah, let me just jump in on that. In spirit, I agree. You don't want to exclude any failures. The question becomes, what's the objective of the test? And if the objective of the test is to demonstrate the reliability over the life of the product, then anything that is realistic, that represents the maintenance or supply chain or manufacturing or design can obviously go into the life of the product.
Right. If your test fixture fails, or the measurement system you're using in the testing fails, then I don't count those. Those are sensor data type situations.
Yeah. Yep. What some companies do, and here's where it comes down to objective. Some companies say, okay, we're going to demonstrate the design reliability, and then in 3 weeks or 6 months or whatever, we're going to demonstrate the manufacturing reliability. In other words, we're going to bring in all the manufacturing processes, because the design this might be a time issue. We don't have the manufacturing processes all figured out. We're in the design stage, and we want to see if the design concept is going to work. So we're going to assume some things we're going to hand build, because we don't have the manufacturing plant set up and the processes. So we do a hand build, and then the question becomes, if somebody hand builds something that's not representative of the manufacturing process,
right,
does that count?
Yeah.
And so I can see some nuance here.
There's some nuance there. And it's true. It depends on what's your objective. Now, my first take on what's the objective is to pass, is what I've heard over and over and over again. We're doing this final test at the end of our program, and we want to make sure that it passes. And we're only going to use enough samples that it has to pass in order for the statistics to work out. And I'm thinking, you're just setting yourself up to wave and obfuscate and ignore issues that you really, really need to pay attention to. It just sets up a bad scenario for your testing.
Well, that was the other comment that triggered when the author of that question talked about demonstration test,
Mm-hmm.
because I usually think of a demonstration test as a test to a bogey, a test to a certain amount,
Right.
but not necessarily test to failure.
Right.
And then you can demonstrate reliability test to failure. You can certainly demonstrate reliability mathematically by testing to a bogey or testing to a certain limit.
Mm-hmm.
And then you're going to have to make assumptions about the failure distributions that go into that calculation. And those assumptions may not be right. So you introduce some possible difficulties depending on whether you're testing failure or not. And of course, I always advocate where possible test failure, so
Yeah.
you can get the failure distribution empirically if you can.
Yeah. No, I agree. It's I guess we agree too much on this one.
Let's keep going. We're going to find something we disagree
Well,
with.
the hard part is that when there's different initiating causes for doing a demonstration test. When it's in a contract someplace, thou shalt do a demonstration test on July 5th, and we'll see what the results are. And then it's contingent on us buying the product. So it's very stressful. You gold plate all of the products that are going into that demonstration test. You treat them with kid gloves to get them through the process. All these other games that are played because it's a condition of sale. And doesn't have anything to do with actually feedback to the design process or to learn anything or to do anything meaningful. Those are the scenarios that I go, well, yeah, if that's what game you want to play, at least be open-eyed about it, that you're not going to get anything useful out of this. So move on, just get it done.
Yeah, exactly. So let's not pay too much attention to that right now, because I agree with you. That's not the right objective. But I'm going to go back to your initial points, or maybe the points from the person who was asking the question. You have the design, you have manufacturing, you have suppliers, you have maintenance, and all of those enter into the subject. There's probably more, but those are some big ones. And so the question becomes, how do you represent those? And some, like I say, some companies do different stages of testing.
Mm-hmm.
But I think the thing that we should agree on is that you have to take into account those factors somewhere. Somewhere we need to look at how the system is maintained, and so that the maintenance doesn't introduce failures. Somehow we need to look at the supply chain, and so that the supply chain doesn't introduce critical failures. And somehow we have to look at the manufacturing processes, so that doesn't introduce failures. And of course, we need to look at the design. So there isn't like one test that necessarily encompasses all of those all at the same time.
No.
And so you may do it depending on your product development process. You may do it at stages, or you may do some of that based on analysis or simulation or modeling. I mean, all of those, but you have to take them into account somewhere. And when you do, they need to be representative. So
I totally agree. The part I still think you need to pay attention to them, even when you're doing a design verification and you're using mocked up parts and pieces like that. It becomes the slippery slope of now if the calculation is on your long-term reliability, and we're looking at these 3 failure mechanisms that we're concerned about, and we're essentially doing an accelerated or a life test for those features, right? And it happens to use the whole system. And we had some maintenance issues, and we had this issue and that issue, and those become censored for that calculation only, for that, say, the wear of some component, and you wanted to see if the wear rate was going to meet your requirements. But that's only one, just as you were saying, Carl, it's just one piece of what your customer will experience in its product's usefulness and how it fails. Yes, there are different classifications and sources of failures. Just because you can identify them doesn't mean it's not there. It just doesn't count. If the calculation is, what's my total expected reliability in a customer's hands, the demonstration test will probably give you, in every circumstance I've ever run into, will give you a better than reality piece of it. Even if you But if you eliminate maintenance, you eliminate supply chain issues and stuff, it'll even look even better than reality. And
Yes.
the thing I've learned over the years is that you can take a absolutely beautiful, wonderful design, and you will make it worse once you add manufacturing, suppliers, and transportation. And most of all, people that actually use your product. It just adds way more variables and way more situations where it's just not going to work.
And that's so essential. If you're going to say this product meets your reliability objectives, then you have to take those things into account.
Yep.
So I'm agreeing there. Let me go back a story that goes back a few decades on to my Fisher Body days where we tested doors. And in fact, I learned a new word. This is back in the 1980s. I learned a word called rabbit. I didn't know what a rabbit was. And maybe some people don't, but a rabbit is a configuration that, since if you look at the door cross dimensions that between the frame and the door shell itself, you get this rabbit, which affects the size of the rabbit affects, that's where you put the seals, and it affects the door closing effort. So you have this, where the rabbits are can affect greatly whether you have a low closing effort or high closing effort, because if the rabbit is too small and you would put a big seal in, then that's going to compress and cause a high closing effort. So long story short, we tested doors, and the question becomes, how many doors do we test to be able to have some confidence? And when I first started out, I didn't think about the rabbit. And so we had the prototype shop would send in doors, and they all met the exact right dimension on the rabbits.
Mm-hmm.
And so then we do 3, 4, 5 doors, and sure enough, the closing efforts were fine. But if the sheet metal was such that the rabbit dimension was too small, closing efforts were way out of bounds. And so we didn't design the test properly, because we should have said, okay, at one end of the tolerances where the rabbit gets really small, what's the closing effort? At another end where the rabbit's really large, what's the closing effort? And we could have designed a test that actually, so we didn't take into account that variation,
yep.
which is essentially a manufacturing variation. And so just that simple story taught me that you can't just focus on the design. If you do focus on the design, you need to be sure you understand the tolerances and create the worst case, so to speak, on the tolerances, and then try to replicate better. If you don't do it up front, then do it down the road, what the manufacturing variation is going to be. Then you have to take into account the suppliers in some way.
Yep.
So you're going to have to look at it all. Whether you do it at the first test or not, depends on your objective.
Yeah. And the part I run into, and I unfortunately have seen it a couple of times, is we do a test, and it was my first real run into this idea that we're doing a binomial based test, and we're going to run X number of units, and if none fail, then we're good. And so the dilemma came is, I think I'll just use 22 for 90% reliability with 90% confidence. And they were running it in a demonstration mode, kind of use. It was pretty close to use conditions, although with gloves on and everything else, very clean environment and all that stuff. And a couple of units failed. And so what they did, what the technicians were taught to do before I got involved with it, was they would just add another unit, and it would accumulate hours and stuff until they had 22 units that had enough time to replicate the duration of the test that each unit needed to see. And then once they got 22 that worked, they'd wrap and say, all right, we passed. And I'm taking a bunch of statistics classes at the point, and I said, well, let me do a calculation. You had 5 failures over this time. You replaced units and put them on there. What if I calculated what was the expected reliability if I have 5 failures out of the 27 units you ended up using? Well, it was way less than 22 that worked. Right? If I started with 22 and went on. And my boss had the argument of, well, what's the difference? We got 22 that worked. He says, well, you're adding a piece of knowledge in there. You you kept going until you passed, right? And every unit you added, you ignored the information it was providing you. You just said, no, we dismiss that. We ignore that. And that's
Oh,
not the same as starting with 22 and staying with 22 and getting the results from the 22.
it's a great case study. A really good case study. I totally agree. I don't like that concept of let's just keep going. We'll add samples and then recalculate. Testing should be a learning process. And that's the other point I would want to answer back to the question about demonstration test is demonstration test is one method, but one method isn't the cure-all, end-all, be-all, because there is the subject of halt. There's a lot of different methods.
Yep.
And so you want to understand what the limitations are to a demonstration test, and that isn't the only thing you do, obviously.
Yeah. Well, it did sound like from the question that they had these other failures and they were doing some root cause to sort out what was the nature or source of that particular failure. So that's good. That should always be, it doesn't matter what testing you're doing, is understand the nature of the failures and source of those failures and go address those wherever they came from. That's a good feature. The unfortunate part with demonstration tests is that we're assuming it's done. We're assuming that it should work, whether it's just the design part or the whole finished product and the whole system of creating the product, is that we make the assumption that we're done. And then we're going to run a certain number of samples or a certain amount of time or under these particular conditions that has a whole pile of assumptions under it. And so it doesn't leave a whole lot of room to actually enjoy when failures occur. Usually it's late in the program.
Celebrate failures. It should be the concept.
Right.
And let's just say this for sure, because we don't want to ignore failures. And so ignore failures at your peril. So if you're doing a reliability demonstration test where you're focusing on design and you have a supply failure or a manufacturing failure, to be very, very careful if you try to ignore those.
Yeah.
Because that can be so valuable in terms of knowledge, and it may represent, it quite possibly could represent what could happen in the real world. And you have to be very careful if you're going to say, well, this would never happen because.
Yeah. Now, I ran into, well, I know I've talked about it in one of the previous 750 plus episodes we've done in the show, but it was one of those amazing studies that I ran across, and it was when I was at HB, and I'm quite sure it's not been published, but it was this, they had a product that they developed and shipped, and they had a very extensive fracas system that kept track of every anomaly that they had. They triaged them and fixed all the ones they should have, essential ones, and then there was this great big pile of failures they noticed that were one-offs or were, at the time, not deemed important enough to have to solve. We're just see what happens. And so somebody on the team said, I wonder if that was the right decision, on this pile that we know about, but we're not quite sure, and we didn't address. And so over the next 2 years, as this product was in the field, they kept track deliberately of the call center data and all the returns and all the other issues. And they invested a bunch of money into doing the failure analysis on a lot of this stuff. And it wasn't too much more than what they normally did because they were constantly doing continuous improvement and field improvement and stuff like that. And then they hired somebody to compare the two databases because they were, for all kinds of different reasons, in kind of different language. So this poor person, she had to go through it. We see this anomaly of a voltage variation that causes a timing issue. And then in the field data, it was the power supply didn't boot up, or something like that. And then worked out as many as she could, the ones that were similar. But then focused in on like 150 of issues that were the top of the fracas system, yet were not addressed.
Wow.
So, and she found that she could identify like 120 of those did occur in the field. And if they had And then the program manager and a couple other folks got on the team and said, if we would have spent one more month of development, we would have solved all those 120 units, and it would have cut our field failure rate in half.
And saved a ton of money in terms of life cycle cost.
Right.
That's one of the reasons I brought in that learning, what you're describing, where I saw the tests did not represent what was happening in the field. When I was at General Motors, I said, okay, we must look at the quality of the tests. We called it detectability. Did the tests detect the problem during product development in order to improve the tests while there's still time before launch?
Oh, it's like the rabbit on those doors. If you don't include that variability, you're blind to that phenomena is going to be a problem.
Absolutely.
Yeah.
Absolutely. So this is just a fun topic. If we go back to our book for a second, we always say, ask why you're doing a particular method. So why are you doing the reliability demonstration test?
Mm-hmm.
What's it for? Did you do a gap analysis first? In other words, are you addressing an issue that you anticipate? And so not automatically doing methods is another important point.
Yeah, definitely an important point. And vast majority of the time when I've run into demonstration tests, it's a customer requirement. There's no other reason for it. And then okay, whatever. That's a subject for a whole nother one. But if you're listening to this and if you've got that kind of question, how do you deal with unreasonable or not helpful customer requirements or regulatory requirements? Those two kind of fall into the same thing. In some cases, we got to do it. And sometimes it's useful and sometimes it just really isn't. Because if you do everything else right and the customer says, well, wait a second, it's a whole nother topic. Let me stop there. If you've got a question like that, or if you've got a question on this one, on this demonstration test in particular, and that was from a listener or a person that asked this question, is like, what do I do here? And I'll spend more time responding to their question directly so they get an answer and don't have to wait for the podcast. But if you've got a question, let us know. Head over to accendoreliability.com/go/SOR, and you can leave us a question there. Or as this person did, sent me an email. My email address and all the other hosts are able to be contacted either through LinkedIn or through our About pages. Plenty of ways for you to get in touch with us. And to the person that's been involved with the show over the years is that that's a cool thing, is to be able to help somebody directly. And we hope that listening to the show is useful also. But if you have a question, we'll try to get you an answer. And it might well end up being a topic that we can explore more in depth on the show. As
you can tell, we hear you because we're taking up the questions as our podcast.
Yeah, definitely. And we certainly enjoy it. So anyway, thanks so much for sending the question along. And if you have another one, send it on over. We're happy to help if we can. So with that, Carl, I'm going to go check my email, see if I got another question.
Sounds good. Good discussion, Fred.
Thanks, Carl. We'll talk to you later.
Bye-bye.
Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.